Solving quadratic equations by factoring. We have an equation here, 4 minus 7p is equal to 3p times 2 minus p. As it is, when I look at it, it is not appearing like a quadratic equation, but it is a quadratic equation. As I can see here, 3p when multiplied by p, it gives you 3p squared. It's a degree 2, hence it is quadratic. Now, right away I cannot solve it for this variable p. I can't find the value of p. So, first step, first step is that I have to write it in the standard form. And what is the standard form of a quadratic equation? That is ax squared plus bx plus c equal to 0. Degree 2 comes first, and then degree 1, and then the constant term. Okay, let us try. Here in the first step, on the left hand side, I have nothing to do. I'll just write down 4 minus 7p. But on the right hand side, it is a multiplication. 3p is multiplied with the 2 minus p. So making use of the distributive property, I'll write down this is 3p times 2. That is 3 times 2 is 6, and the p, 6 and p, 6p. So I'll have 6p. Okay, same way, this 3p times 2 gave you 6p. Now similarly, I will do 3p times p. That 3p times negative p. So 3 is there with a negative sign, and p times p is p square. That is minus 3p square. Okay. So I got 3p square. Right. Now in the standard form of a quadratic equation, I have to have a 0 on the right hand side. Here I have two terms. So let us cancel off one term at a time. I'll cancel this 3p square first. So add 3p square on the left hand side. Therefore add the same 3p square on the right hand side. Now bring down the terms from the highest degree to the least. I'll write down and say this 3p square is there on the left hand side. It doesn't go with 4 or 7p. They're all unlike terms. All three of them are unlike terms. So I'll just write down or bring down 3p square minus 7p plus 4 is equal to, this is cancelled off, 3p square negative and positive gone. On the right hand side, you have only 6p left. Now in the next step, let us cancel off that 6p also. Subtract 6p, minus 6p, minus 6p. I'm writing it right under 7p because they are like terms. Okay, now we are good up to this point. First step, I distributed and I got 6p minus 3p square. Then I cancelled off 3p square by adding 3p square on both sides. Now I am subtracting 6p. Okay. Let me bring down 3p square minus 7, negative 7 and negative 6. Add them together. Gives you negative 13. So p is also there. I'll write negative 13p. Those two are the like terms. You can add them together with a negative sign. Bring down 4. That is plus 4 you got. And on the right hand side, plus 6p minus 6p got cancelled. Now you see, it is exactly in this form of a standard quadratic equation like ax squared plus bx plus c. Instead of x, you have p. That's all. 3p square, 13p plus 4. Okay. Now, let us identify the values of a, b, and c. You see that a is equal to 3. Your b is negative 13 and C is equal to 4. So this given equation we transformed into a standard form, and now you have the values of A, B and C. Now following the process of finding the factors, what you do next step, I have to find the product of A and C. So what is A times C? That is 3 times 4 gives you 12. So I'm looking for two numbers whose product is 12. That 12 is the product and the sum is negative 13. Find two numbers and write them down here whose sum, that is adding the two numbers, should give you negative 13, and multiplication, the product, should be equal to 12. Remember, you got this 12 by multiplying A with the C. 3 times 4, that is 12, and negative 13 is the value of B, that is the sum of the two numbers. This B is negative 13, that goes here always. Now, what are the two numbers? Here it's a kind of case where the product is 1 less than the sum. So whenever you get into such scenario, when the difference between the sum and product is 1, remember 1 will be one of these two numbers. So 1 is going to be either the first number or the second number. Okay. Suppose if 1 is the first number, 1 times 12 is 12. So 1 times 12 is 12. That condition is satisfied. When 1 is one number, definitely the other number has to be 12. So 1 time and 12 are the things I took, and the product gave you 12. But the problem is with the sum. The sum says negative 13. How do you fix this thing up? In order to get negative 13, I have to just change both the factors to negative 1 and negative 12. Still, you look at the product, negative 1 times negative 12 is still positive 12 only. And add those two numbers, negative 1 plus negative 12. On adding these two will give you negative 13. When both are negative, add them and keep the negative sign. You can even verify using your calculator. Okay, so these are the two numbers, negative 1 and negative 12. The first number, negative 1, is bigger than negative 12. So let me write negative 1 first. Always I prefer to write the greater number first and the lesser next. That helps us a little bit, but you don't have to. You can write negative 12 here and negative 1 there. That's fine. Okay, once we have this, we broke down this 13 as 1 and 12. We are going to do the same thing in this quadratic equation. That is, I have now 3p square, that minus 13p I am going to write as minus 1p, or just p. P means it is 1p only, minus 12. So this minus 12p, of course. So minus p, that's 1p, minus 12p gives you minus 13p. And next I have plus 4. So let me go ahead and write down plus 4. And on the right hand side, it is a 0. So here this quadratic 3p square minus 13p plus 4 equal to 0 is extended into 4 terms in order to factorize, to find factors. Right. Now to find the factors, in the previous videos I explained this making use of a box method. Draw a box and fill in these 4 terms and then taking out the factors. We did those again and again. So in this I'll show you how to use grouping method. Let us group the terms and then find the factors. Okay, first I have the first and second term I'll consider as one group, and this third and fourth term as a second group. Okay, now what is the greatest common factor between this first and second term? We see nothing but p in both the terms, p square here, and that's p, and 3 and 1, nothing common between 3 and 1, it is just 1 I can write. That is 1p is taken out as a factor. So this 3p square I have to divide by p. What is 3p square? 3p square on dividing by p. 3 is left, and also p square over p gives you p. That is, I'll write down 3p. There is a minus sign, I'll write minus. From 1p, from this p, if you take off that p and p cancelled off, you are left with only 1. So you have p times 3p minus 1. This first and second term put together gave you this 3 times 3p minus 1. Verify. P times 3p, 3p square, and p times 1, that's p. That's fine. Now this third and fourth term, what is the common factor between these two? Between 12, that is negative 12 in fact, and 4. Between 12 and 4, the greatest common factor is nothing but 4. So I'll write down 4 with a minus sign. Start the parenthesis. So this negative 12p, if I divide by negative 4, negative sign cancelled. 12 divided 4 is 3, and also I have a p there, so I'll write 3p. 12p over 4 is 3p. Then this 4 I have to divide by negative 4 because I have taken out negative 4. So what is positive and negative? The quotient between positive and negative, that is minus sign. 4 divided 4 is 1. Okay, so the third and fourth terms gave me 4 times 3p minus 1. Verify. Negative 4 times positive 3p is negative minus 12p. Negative 4 times negative 1, positive 4. Everything is fine. Now look at these two. What do you see in these two terms now? I can see 3p minus 1 being repeated. 3p minus 1 and again 3p minus 1. So that 3p minus 1 can be taken out as a common factor. Take out 3p minus 1 as a common factor, and what is left over? From this first term, p times 3p minus 1, p minus 1 came out. You are left with another p here. I'm talking about this p. Okay, there is a minus sign. I'll write minus. This 3p minus 1 came out, left behind 4. Even you can just follow it in the same way, like how I divided p here in the same way. If I divide this by 3p minus 1, that's cancelled off. You have p left over here. In the same way, this is gone. You are left with 4. Now, these are the two factors. Now, go to the zero product property to get this 3p minus 1 equal to 0, and p minus 4 is also equal to 0. These are the two linear equations, and we are going to solve them to find the value of p. 3p minus 1 equal to 0. So I'll add 1 to cancel off that whole thing. 1 and 1. Leaving behind 3p is equal to 1. Then divide by 3. Divide by 3 gives you p is equal to 1 over 3. Similarly, add 4 in the second equation. Add 4. Okay, that's 4 plus 4 plus 4 to cancel out this. P is equal to 0 plus 4 is 4. That is your second value of P. Hence my answer, this P is equal to 1/3 comma 4. These are the two values of P. Okay, and you can always go back and verify your answer, this solution, by substituting in the given equation over there. On substitution of the values of P is equal to 1/3 on the left hand side and right hand side, you will get a true statement, right? So that verification can also be done. All right, did you get the process? Like here, using the distributive property and then bringing everything onto the left hand side, you got the quadratic equation. After the quadratic equation, and in this particular example, I showed you how to group the terms, grouping the terms and taking out the factors. If you have difficulty with this grouping and factorizing, you can just draw a box and take out the factors. Anyway, it is fine. We just have to find the values of this P, the variable. Now in this, I have two more problems for you to try. The first one is 8 minus 3P, 13P is equal to 6P times 6 minus P. And the second problem is 5 minus 17P is equal to 8P times 3 minus P. Follow the same procedure and try to find the value of this variable P in this. Okay, please try. Thank you.